Right, team, we're starting to record. Here we go. So, today's lesson, I'm going to combine 14E and 14F. 14F is only, hopefully, to give you some value to work with, to get your head around it. And then 14E, I'm going to come back and just make sure that you understand symmetry properties. So 14E is your most foundational part. If you don't understand 14E, then you can't do the sketching part. You have to get 14E first. Okay? So, let's get our head around. In your notes, what I want you to copy, because you have to memorize this eventually, I will show you another method I can teach you. It takes about 5 minutes and you'll memorize all 15 of these exact values. But you need to know these terms. So if I said, what is the sign of pi on 6? You will need to know that it equals to half. By the end of this session, and from here on, I will be testing you each time you come in. I'll call out your name. And I may say something like, what's cos of pi on 4? What's cos of 45 degrees? And then you need to be able to tell me. All right, let's do you, but I'm challenging you in a different way. What is tan of 3 pi on 4?
3 pi on 4. That would be square root 2 over 2. Oh, sorry, that would just be 1. Sorry. Minus 1.
Very good. So you're almost there. So what he's doing there, he's figuring out the circle. In order to do what I just did with Dylan there, you need to know 14E. Okay, you need to understand how to look at you have to picture the unit circle. Okay? So, right now I just want you to copy that chart down. This is a chart that you'll need to memorize. You need to know that off by heart. It's kind of like your times tables. If you're doing circular functions and you don't know that, then that's already a step that I know that you're going to struggle in 14H, 14F, 14E, and onwards. So you have to know these exact values. Okay, so copy that chart down. As you copy it down, today's lesson, because I was away on Monday, I want to make sure you understand the purpose of symmetry properties. Your goal is to see that triangle. Okay, your goal is to see why this is true along the way. And I'm gonna set it up so that you can see how we're doing this, okay? And I'm going to use this exact value to illustrate my point, okay? I'm going to use this exact value table to illustrate my point. So please copy this down. Make sure to have the exact values in your notebooks, okay? In your notebooks. Make sure to copy it down. You need to memorize them, okay? There should be 3 by 5. 5 special angles, 3 functions. Sine of 0, sine of 30, sine of 45 degrees, sine of 60, sine of 90. Same thing with cos and tan. So copy that down first. Means I might as well mark the roll. Looks like we have. Let's see, we got Andre's here, Aaron's here, Ryan's here, Dylan's here, Jem is here, Nathan's here, Jules is not here, Jacob is here. Max is here, AJ's not here, Lohit's here, Zach's here, Jordan's here, Jacob White is here, Matthew is here, Ollie is here. Right, team, here we go. I'm going to go through the explanation, okay? So, I'm going to still leave the chart there. If you're worried, it's still there. Here we go. So, 14E, want you to picture the unit circle. Okay, so this is your unit circle. Unit means that it's a radius of 1. So I'm going to put the values here. This is 1, 1, negative 1, negative 1. So I'm going to put the points in so that you can visualize it. Okay? Now, let's have a look at this chart. So 14E and 14F go together. I've got a worksheet for today that you're going to practice those skills. Let's have a look. We've got sine of 30 degrees. They say that that's equal to half. Okay, what I need you to understand is, what does it mean? What is it talking about? When you have an angle of 30 degrees, what is half? What is sine? How does that translate to a diagram? What it's trying to say is that in your unit circle, if you created, starting 0 degrees is here, that's where 0 degrees is. If you move from here around the circle and you made a 30-degree angle, okay, it's 30-degree angle, so I'm going to make Let's say that's 30 degrees there. So I'm going to draw on the diagram. Say this is 30 degrees. Okay? From here to here is 30 degrees. Radians talks about the distance. So the distance I've traveled from here to here is pi on 6. That's what they're trying to say. Okay, so pi on 6 or 30 degrees, so angle's 30, pi on 6 is the distance. Now I'm here, right now on the circle, on that unit circle, I am currently sitting at this point. This is where I'm at. This point has an x and a y coordinate on the Cartesian plane. Now logically, we know that the maximum distance was 1. If you're moving around the unit circle, the x distance is getting smaller, isn't it? So it gets a maximum of 1, it gets smaller than 1, and it gets to 0. The x value gets to 0. Here the y value is at its maximum, which is -1. As you move across, the x value now becomes the maximum, yet the y value is getting smaller. Now let's recap. Sine function and cos function. What does the sine function represent again? Is it the x coordinate or the y coordinate?
Y.
The y coordinate. Okay, and for those who've forgotten why that is the case, when you write sine, remember back in year 9, you said sine of an angle is opposite of a hypotenuse. If I drew that triangle right now, so here we go, I'm going to highlight, that's your hypotenuse, and I drop it down, so from here down, you can see I've got this right triangle here, so I'm going to draw it again. This is 30 degrees. Right angled, that's your y value, that's your x distance. This is a radius of 1, okay? So, according to sine theta, can you see opposite has to be the y value over hypotenuse is 1. This is why we say sine theta represents your y values, okay? So let's have a think about what you said here. You said sine of 30 degrees equals to half. You just told me, or thought about, sine is the y values. What are you trying to say? Is right here, when you make a 30-degree angle, sine talks about that height. So that y value, right there, you're saying that's half. What about cos? Cos is the x value. So x value at 30 degrees at this point, that length there, is what cos of 30 degrees means. Okay, so based on the chart, what's cos of 30 degrees equal to right now? Root 3 on 2. Based on the cos of 30 degrees, that tells me root 3 on 2. So that means this coordinate is root 3 on 2, and this is half. Okay, so I'm going to draw another circle just to keep it all clean for you to see. Here we go, we've got another unit circle. I'm just saying, when you create a 30-degree angle, this point here is currently root 3 on 2, half. Okay? Are we following what I'm saying so far? Does that make sense, at least? Okay, so that's the first step. Second step is to understand this. This is what exercise 14E is trying to say. 14E is trying to say, all right, so you got 1 point. Great for you. Notice the angles that you need to memorize is only from 0 to 90. You don't need to know 360. You only need to know 1 of the quarters, because that's what we're going to use. That same 90 degrees, we're going to use it for all quadrants. So all you needed to know was this triangle here. I'm going to draw it again. This has a length of root 3 on 2, and it has a height of half. When they say symmetry properties, you see, if I took this triangle and I flipped it over here, okay, I flipped it horizontally, okay? So that means there's a vertical axis here, mirror, and I flipped it across. Can you see that I can get the same triangle at this point, mirrored image? That would mean that this is also 30 degrees here. That's still 90. And the length is still root 3 on 2. And the height, oh, the pen's dead. This is not good. I'm going to try this. It's been happening over the last few days. I'm just going to disable it. And then that happens. And then I'm going to enable it again. How's it now? All right, we're back. All right, the pen's working again. All right, here we go. Sorry for the disruption there. Can you see that if I had the same triangle, this is what 14E is about. If you can have the same triangle, but in this quadrant, same triangle, except it just looks different, just oriented differently, then the adjacent side to it is still root 3 on 2. This is the adjacent side, which is still root 3 on 2. And the opposite side to this triangle is still half. If that is so, what is this coordinate right here? See, that's what 14E is trying to say. So I moved from here, I got up to here, that was root 3 on 2 and half. But if I moved all the way here now, what's the coordinates here? What would the coordinates have to be? Very good. The x value is still the same. The only difference is over here, it's a negative root 3 on 2. So the coordinates here, you would say it is negative root 3 on 2 and positive half. Okay? So, but the angle is clearly different. You can't say 30 degrees. That's not 30 degrees. I had to travel from here, 0. I had to do more than 90. And I had to do an extra 60 to get there. Do you see what I'm doing? So this is 90 degrees plus 60 is 150. I'm missing that 30 degrees. This is called symmetry properties because you can see this angle that I'm drawing here right now. So notice I'll go from here all the way to here. That was 90 plus an extra 60 degrees, which is a total of 150. Oh my God, the pen. 150 degrees. Okay, so that means if I ask you what is the sine, see at that point, if I said sine, which means find the y value at 150 degrees. If I said sine 150 degrees, I'm no longer in this first quadrant. I'm not in this first quarter, I'm now in the second quadrant based on what I moved, but I know the height has to be half. And that's what I was trying to show in the video, that if you typed in your calculator now, I'm going to go open up my CAS. You can open up your CAS as well if you want. Might take a while to open. But right now, this is what we call symmetry properties because we know sine of 30, which is the only one we knew before. In our exact value, sine of 30 was equal to half. But it also means now sine of 150 also equals half because all you're interested in is the y values. Cos would be the x values. X is different. X will be negative in this region. Okay, so have a think about it. That's probably what the deepest thing that you have to take out was to understand that part. Now, watch what happens. I'm going to use my CAS. Here we go. I'm going to use my CAS up here just so you can see. I want you to see that when I do sine, so trig next to the 7, trig, I'm going to do sine, make sure it's in degrees mode. If I do sine of 30, we know was half. That was already a given. But notice when I do sine of 150, it's also half. Because it made sense in the diagram that from here to here, if that was 30 degrees, I already knew the height was half. If I did the other direction, 30 here, well then the angle has to be up to this point. Since I already know this is 90, then I know this has to be 60. That's why I know together it's 150 degrees. Sine of 150 should be asking the height. That's why it's still half. Now how does symmetry properties work? Well, that means in a unit circle, I can have another triangle that starts from here and I go down 30 degrees and I land at this point. So the question is, in this triangle, what would the coordinates be here? Very good. So again, this is the x and y values. The x is still negative root 3 on 2, but the height is now negative 1 on 2. So here's negative half, and this is negative root 3 on 2. Okay? Now, you might be wondering, well, how does this help me answer the question? So the one I gave to Dylan before, you need to picture where you are in the unit circle using your exact values to understand. So let's try. I want to do cos of 5 pi on 4. Okay? I'm going to do cos of 5 pi on 4, and I'm going to get you to understand the unit circle here. So let's have a look. Cos of 5 pi on 4. Your job eventually, when I ask you these questions, you need to be able to answer off the bat. It's like saying 5 times 8. You have to be able to do that. Okay, so if I ask you what is cos of 5 pi on 4, you should already know where I am in the unit circle and what the exact value is. So using your exact values table, so you got the table over here. Okay, the only angles you got, pi on 6 is 30 degrees, pi on 4, pi on 3, pi on 2. Those are the only things you've got. Okay, let's have a look here. How would I do cos of 5 pi on 4? The first thing you need to figure out is, where am I on the unit circle? Okay, now 5 pi on 4 in terms of fractions, 5 over 4. Is it bigger than one whole or is it smaller than one whole? Bigger. Bigger by how much?
Pi on 4.
By a quarter. Yeah, 5 over 4 is one whole plus an extra quarter. Yeah, so I'm going to write that down. This 5 on 4 is the same thing as saying 4 out of 4, so that's one whole, plus an extra 1 pi on 4. True? Have a think. So this is where fractions come in. You need to know your fractions. So 5 on 4 is the same thing as 1 plus an extra quarter. And this here works out to be 4 divided by 4 cancels out to pi plus pi on 4. You're asking, what is the cos of this distance? So this distance will tell you where you are in the unit circle. So let's think about it. On the unit circle, where is pi right now? Right here. Very good. It's where the 0 point is. So here's 0. This is where 0 is. Pi is one full distance. That's half a circle. All the way is 2 pi. So I've done 1 pi, but they said plus an extra pi and 4. Now pi and 4, go back to your chart. What's the angle for pi and 4? What's pi and 4 the same as? 45 degrees. So from here, I'm adding on an extra 45 degrees. That's where I'm at right now. So on your diagram, you should draw in, this is where pi is, and this is where you're adding on an extra pi on 4. 45 degrees. So when you draw your diagram, can you see, listening? This is where pi and 4 is. You're adding an extra pi and 4. This is 45 degrees. Can you see you get a triangle? This is a triangle here. This is the triangle you have. You have 45 degrees, 90 degrees there. This is the point you've got. Hypotenuse is still 1. But this is what you're interested in. You're looking for cos. So in this triangle, cos is the x length. That's the length that you're looking at. Cos is the adjacent. So this is what you're looking for. Now, how do you know what that value is? You go back to your exact values. Look at your exact values chart. We do have the property if it was 45 degrees. We know when it's 45 degrees, which I'm going to draw over here, when it's 45 degrees, this is where 45 degrees is, in the first quadrant. That's equivalent to pi on 4. We already have an exact values chart that tells you how far that is. What is cos of pi on 4?
Square root 2 over 2.
Very good. Root 2 on 2 or 1 on root 2? Same thing. So if you rationalize denominator, it becomes root 2 on 2. If you leave it as it is, it's 1 on root 2. So what that tells you is this is 1 on root 2. But can you see this triangle right here? This triangle is no different from that triangle over there. The only difference is the positioning. So if this is root 1 on root 2 as the adjacent, that means this has to also be 1 on root 2. What's the difference though? What's the difference between this length and that length? What's the key difference? What do you see? One's negative. See, this is on the x value, this is positive. That's the negative side. So this coordinate here, you wouldn't say it's positive 1 on root 2. You would say this coordinate right here has to be negative 1 on root 2 because that's the cos section. Whereas the y value, what is the y value? It has to be negative as well. But how do you know the y value? It is based on the opposite. Now back to your exact values. What is the sine of 45 degrees? Because sine tells you the y values. What's sine of 45 degrees? What's sine of 45 degrees? 1 on root 2 as well. This is why I'm saying you have to know your exact value. So here, I've got 1 on root 2 as my sine, 1 on root 2 as my cos, and I'm using this triangle to apply to, doesn't matter which part of the unit circle I'm applying it to know is it positive or negative in those regions. So clearly, when I'm finding the cos is clearly a negative answer. It's negative whatever cos of pi and 4 is. And using your exact values, you knew that was negative 1 and root 2. Okay, so this is what I mean. Eventually, you'll be able to do all of what I just said in one go in your head, because all you need to figure out is where are you on the unit circle. Okay, let's do it again with example B. Let's have a look at example B. Your job is to figure out which quadrant you're in. Okay, so here we go. Unit circle, Q1, Q2, Q3, Q4. Your job is to find sine of 11 pi on 6. Okay? I want you to tell me, where is 11/6? So think about your fractions. 11 over 6, where is it closest to right now? Which quadrant? 1, 2, 3, or 4? The fourth. Dylan says fourth. Where else are we all sitting? I'm asking, where is 11/6? Because 11 pi on 6, I want to know where I am at. The fourth. Because 11 out of 6 is closest to 2. True? If I were to write this again, this is the same thing as writing 12 out of 6 minus 1 pi out of 6. So if you think about where is 12 pi divided by 6, that's the same thing as writing 2 pi. 12 divided by 6 is 2. This is why it gets a lot of students, because your fractions, if you're not strong at this, you can see why it gets tricky. Where's 2 pi? See, I'm always trying to convert this into a nice whole number, because then I know even pi's over here, odd pi's are over here. So 2 pi must be over here. But if 2 pi is here, I'm minusing pi and 6. So I'm not adding. See, adding means you've got to go clockwise, anti-clockwise, sorry. Minusing means you go backwards. And I'm minusing pi and 6. Now pi and 6 as a degree. Look at your exact values. What's pi and 6 the same as? 30 degrees. So I know if I were to subtract it, I'm going from here, I'm subtracting to about there. That's where I'm at on the unit circle. So if I were to do it, this is what it looks like. From here to here, that's what minusing pi on 6 will look like. This is my triangle. That's my triangle. So if I drew the triangle a bit bigger, I'm trying to find, if this is 30 degrees, I'm trying to find the sine. Which one's sine? Sine's the opposite. So I'm looking for this height. That's what I'm looking for. But clearly, is the sine negative or positive here? Negative. The y value is negative there. So I know the answer has to be a negative. That's the first thing you do. That's what we call symmetry property. So it's the same thing as negative sine of, and this is where you use your exact values. You're saying it's the same as that 30 degrees that you had. You had 30 degrees up here. That's pi on 6. Using your exact values, you know what sine of 30 degrees is. So look at your exact values table again. What's sine of pi on 6? Half. Okay, so this is what I mean. You need to know your exact values at that point. You now know this is negative half. Sine of pi on 6, using your exact values, it's equivalent to half. So your overall answer, when I ask you what is sine of 11 pi on 6, you should be able to have a think and then tell me it's negative half. Okay, so I've got a worksheet that works on this idea. There's about 2 pages worth here. Well, I'm training you to think, where are you in the unit circle? And then using your exact values to answer this question. Okay, now, what I'm going to do is I'm going to give you a couple. I don't need the answer, I just need to know which quadrants I'm in. Okay, your skill is to figure out the quadrants. So, let's make it up. I'm going to make up a few now, okay? So here we go. Example, let's go question hashtag A. What is the cos of 7 pi on 6? B. Sine of, say, 5 pi on 3. C. Tan of, you don't need to know the values, I just want to know the quadrants. Which quadrants I'm in? 23 pi on, let's say, 12. D. Cos of 25 pi on 6. Okay, so now I want you to think. Let's draw a unit circle for each one. Your job in the first step is to be able to figure out where I am in the unit circle. Okay? Because once you know where you are, then you know if it's positive or negative in those regions. So let's start off with the first one. 7 pi on 6. You have to think about the fractions here. 7 over 6. Is that closest to 1 or is it closest to 2? Second quadrant. Third quadrant. So what are we thinking here? We've got 7 over 6. That is the same thing as writing 1 pi. So hopefully you were able to figure out that's the same thing as writing 6 over 6 plus an extra 1. So 1 pi is over here. This is where 1 pi is. This is where pi is. Adding pi and 6, you know you have to be in quadrant 3. The answer for the first one. Quadrant 3. Second one.
All your arguments just crumble.
Let's do this. B. Where is 5 pi on 3? So you need to know where 5 pi on 3 is. So have a think. 5 over 3. Where is this one now? We've got fourth quadrant. And 5 pi on 3, if you were to rewrite this, this is closest to 6 pi over 3 minus pi on 3. Because 6 pi, 6 over 3 minus 1 over 3 makes it 5 over 3. But 6 pi on 3 is equivalent to 2 pi. So once you get this step, once you know where 2 pi is, you know it's over here. This is where 2 pi is. Minus is you go down. So clearly, you're right. Quadrant 4. See what I'm doing? Your first skill is to figure out where the quadrants are. So let's go back. Number C, tan. I'm only interested in 23 pi on 12. Where is 23 pi on 12? Quadrant 4. Very good. Because 23 pi on 12 is the same thing as writing 24 over 12. Take away pi on 3. Oh, sorry, pi on 12. Okay, so we know 24 pi on 12 is the same thing as 2 pi minus pi on 12. Here again, we're in quadrant 4. Okay, that's the first skill. This is 14E. 14E, okay? Last one, cos of 25 pi on 6. First quadrant, very good. Okay, because 25 pi on 6 is the same thing writing 4 pi with an extra pi on 6. So 4 pi is over here. And I'm adding an extra pi on 6, so I should be in quadrant 1. Now, how do you apply 14E? 14E, listening, 14E now asks us, I want cos. Once you know it's in quadrant 3, cos is the x values. So if you're here, is my x value positive or negative here?
X. Negative.
X is negative. You can see the x-axis, that's in the negative region. So that's why you know your answer, whatever it is, it has to be a negative answer. Next one, sine. This is sine. I'm trying to find the sine. So I found the position, now I'm finding sine. Sine is the y value. Is the y value in this region negative or positive? Negative. So you know the answer to it has to be a negative value. We'll work out what the value is later. Okay? Let's do the same thing for tan. Tan is the gradient, which is the slope of the line. So here we go. We've got, this is where quadrant 4 is. What kind of gradient is that? That line there, is that a negative, positive, zero, undefined line?
Negative.
Negative. So I know the answer has to be negative. And then I go over here and I say, all right, well, we chose quadrant 1. It's over here, cos. Cos represents the x values. Is that positive in that region or negative in that region? Positive. So, already, you have just done exercise 14E instead of memorizing. So I'll show you what 14E looks like. Most students memorize this table. This one here. That's a lot to memorize there. Okay, there's about 16 or 15 of those that you need to learn. It's too much. Get it by understanding what the unit circle is trying to describe. Then you don't have to memorize this. Okay? Or the ASTC stuff. You don't need that. You don't need to know A is all functions are positive. You know, S for sine positive only in this region. You don't. Because you're just looking at the X and Y coordinates. Okay? Now, I'm applying today's exercise for you. We've done all the signs. We know that A was negative, B was negative, C was negative, and D was positive, you're missing a value now. So how do you find the value? This is where you use exercise 14F, exact values, to help you. Okay? So here we go. How do I do the first one? First one, we knew the answer had to be negative because we knew this triangle, listening? We know this triangle is the same as the triangle in the first quadrant, where you said it's pi, adding an extra pi and 6. So you know pi and 6 is 30 degrees. All you need to do is go back to your exact values and figure out in your own triangle, when it's actually 30 degrees, what is cos? Because you're looking for cos. That cos is the same cos value over here. So cos of 30 degrees, go back to your exact values. What's cos of 30 degrees? What's cos of 30 degrees? Correct. Very good, Ollie. Thanks for repeating that.
Thanks, Dylan.
So then we've got minus as our answer, and that's root 3 on 2. Can you see what I'm doing there? That's applying 14F. But if you wanted to understand 14E, that's all it was. Find the quadrant, find the sign. That's all you're doing. 14F gets you to apply the values. Your job is to memorize that chart for 14F. Okay? So I'm going to give you a sheet. Now I'm going to get you to have a go using your chart. And then it's currently 12:50. In the next 20 minutes, I'm going to give you 20 minutes to have a go with this. I'm going to teach you my method to memorize all 15. Okay, so I want you to engage with that exact value, and then I'm going to teach you a method where you can learn that in 5 minutes and you'll remember all 15 of them. Okay, so I'll show you how to do it by hand, and in the meantime, if you want to know your results, I can call you up and then...
So we'd like to know as a group. You can announce on yourself, not like...
No.
I'm shitting myself. Let's get some predictions.
I remember the question.
Predictions.
That's Dylan, read it.
What is it?
What's the answer, Dylan?
Bro, how am I supposed to know?
Dylan, what's the sign? Big.
I think I remember.
Oh, like the
Oh, no.
The season was cancelled.
Have a go with this sheet. You got 20 minutes. Then I'll show you how to memorize these
We like
ones
to know
here.
results.
And I will then tell you results once I answer this question here.
Oh, man. Stop racing. Someone else played I don't really want to. What? Why are you rating at me? I was agreeing with you. Why are you using my pen? Hey, I'm doing the sheet. No. Give me your pen. Give me your pen. Increase my mathematical skills. Although you can pass the use your pen. So you like decrease just right now. I was shitting myself. This is what I did.
Yes, that's enough.
Yes.
It just means it's important to be the same.
That didn't go well. What? Nothing. Except for like 10. Wait, Ryan actually had 60.
Yeah, 1060 is root 3.
Yeah.
That's what I said.
Right. I thought he was talking about something else. Don't worry.
Yeah, exactly. Fuck you, Dylan.
Man, what is that?
Alright, solutions.
Oh,
That's the
guys.
Let me project it on screen for everyone to know.
Yeah, you can just show us.
Can I just show you?
No.
Why? I thought we're confident.
Yeah, we're confident. I'm confident. All of us confident. You can show all of us first. We're going to roll water.
Oh, whoever wants to come up first, line up here.
You go.
Will have been shown to everyone. Is it?
First person to go up.
Oh, okay, let's go.
I go up. I go up.
No, it won't.
Alright, Matt, we can do it.
So did anyone get 100%?
So you coming around or we coming up?
You're coming up.
Oh, okay.
It's mine. We're going boys. Come on, boys. Boys, get it. We made a rule. Whoever goes first.
No.
Wait, you can see everyone's results still.
Can you?
Matt, you failed.